I'm sure we've all recognized the loud, annoying, high-pitched whine of an ambulance passing. But have you ever wondered why that when it comes towards you the sound seems more high-pitched than when it's moving away from you? Or have you ever wondered how the police magically know the speed of your car after just pointing his magic ray gun at you? This phenomenon is called the Doppler effect. So let me explain this in the simplest way possible. Here's the ambulance, and there are two people hearing the siren of the ambulance. Person B is further away down the road than person A. Person A is hearing this. Person B is hearing this. This is what the sound waves look like when the ambulance is stopped in one place. Both person A and B can hear the same thing. The lines represent wavefronts. Wavefronts represent the corresponding points of a wave that is in phase, or vibrate in unison. The ambulance moves towards person B, and as it moves, it had emitted more wavefronts at different positions. Here, here, and here. These new wavefronts catch up with the ones that were emitted before, and so the wavelength in front of the ambulance is smaller than the wavelength behind it. Note that the wavelength is the distance between each wavefront. Thus, person A hears a lower frequency, and person B hears a higher, due to the change in wavelength, as frequency is equal to speed over wavelength. This does not only have to be an ambulance, it could be a duck in a pond, a star emitting light, it could be any type of wave that is being emitted. The Doppler effect also applies to electromagnetic radiation. In terms of light, let's use this star for example, and this astronomer looking at the star. He can calculate the speed of the star. If the star is moving away from him, he will experience a lower frequency of light. Now, a higher frequency in comparison to the original frequency of the light wave means that the light will be bluer, and a lower frequency means that the light is more red. Since the astronomer is experiencing the light moving away from him, he will experience a redder light. This is called redshift. So what about here on Earth then? Let's go back to one classic invention that I mentioned earlier, the speed trap. When a speed trap is aimed at a car, a beam of EM radiation, microwaves or infrared usually, is reflected off the car. The reflected beam undergoes something called a double Doppler shift, where the reflected beam is emitted from the moving source. The device will then receive a higher frequency beam due to a shift in wavelength, and therefore the speed of the car can be calculated from this shift.